mathematical concept. It is widely used in all the fields. For example, jewelry and construction of architects, and we construct a building and designer clothing and automobiles, and everywhere we use this concept of symmetry to make an object which is looking good and beautiful. We need to make that into some of the equal parts, like which is looking similar on each side, on either sides. So to make it all the things in the similar way and familiar way, we need to use this concept of symmetry. For example, to make a building, to construct a building, we need to use the concept of symmetry, because, for example, a building is constructed on each side. The doors and windows. So, it's constructed. For example, we have taken in this manner, and this is the building, and windows are constructed in this manner. So, let's see here. If we take any one of the figure, that is divided into some of the parts. Some of the parts, that is two parts. We divide this figure into two equal parts. Then we fold this figure along with some of the line, and then the two parts will coincide each other. This is called line of symmetry. For example, we draw a line on this particular part, and between of it and particular part we have drawn a line, and along with the line, along with this line, we fold this figure. Then the two parts will coincide each other, and then this is called as line of symmetry. And we have taken any one of the picture, which is, for example, Taj Mahal. We take Taj Mahal and picture of it and divide it into two parts along with a particular line, and that is divided into two equal parts, and we fold that picture and they coincide each other, and this is called as line symmetry. So let's learn about reflection of symmetry. We have learned line symmetry. Reflection of symmetry. Reflection of symmetry is nothing but we take an object or picture, an object we have taken, and we took that object in front of the mirror. For example, this is a mirror. We took an object in front of the mirror. For example, the person standing in front of the mirror, it's look like the same thing. Looks like similar. These two objects are looking like similar, so this is called reflection of the symmetry. But we need here, when we find the object in the mirror, so it becomes like left to right, right to left. This we can understand by taking an alphabet in front of the mirror. Let's see. We took an object, an alphabet in front of the mirror. Let's see. This is in front of the object. In front of the mirror. This is a mirror. If we write R and take R in front of the mirror, this is actual image, and we see this object in the mirror. It looks like similarly just opposite to that particular thing. So this is just reversely it's looking, and it is an object which is the reflection of the object, and this is actual object and this is reflection of the object in the mirror. So if we take any one of the thing, like for example we take L, so it looks like same thing but opposite to that. So this is a mirror of, this is image of that. So if we take M, letter M is taken, and we have seen that this M in the mirror, so its image, its reflection falls like same thing. There is no difference between that and this, because its reverse, when it is reversed, it looks like same thing in the mirror image. We take W and it also looks the same in the mirror image. So this is called a reflection of the symmetry. And up to now we have learned lines of symmetry and reflection of the symmetry. Let's learn line symmetry. For the sum of the figures, take the line segment which is 10 centimeters and name it as AB, and using point A make an arc. By taking more than half radius, using A we made an arc, and using A we made another arc and down of the line segment. Now use the point B, cut this arc and this arc. So we got two arcs and join these two arcs with a line segment. So we draw a line segment, and this is nothing but perpendicular bisector. We have already learned in constructions. So this is the perpendicular bisector of AB. So we call this perpendicular bisector because it divides into two equal parts. And if you take this point as O, O to A is 5 centimeters and O to B is also 5 centimeters. So it divides into two equal parts. So what we have drawn the line, that is called as line symmetry. And we draw a line symmetry for a line segment. For one, so we have drawn a perpendicular line for a line segment which is 10 centimeters. So this is called line symmetry. So it has only one line symmetry. If we are trying to draw the perpendicular bisector for it, so there is no other line we can draw as a perpendicular bisector for this diagram for line segment. So for this one bisector we have drawn, for bisector we can draw one line of symmetry. For example, we have taken any line segment which is 10 centimeters, and then we draw along with a point, particular point we have taken which is in between the line segment, that is 5 centimeters. We have taken one point. So along with this point we draw any other line, and this line also will divide the line segment into two equal parts. We can take another line which this line also will divide into two equal parts. In that way we can draw infinite lines for this line segment. So that what we understood from here, from this, so a line segment has infinite lines of symmetry when we draw in this manner. But when we draw perpendicular bisector, then it has only one line symmetry, and along with the bisector we draw in other methods like divide into infinite lines of symmetry.